Good evening, everybody. It's a pleasure to be here amongst the senior of the area and industry, as well as the youngsters who have come along on this particular aspect. I'm basically going to talk about both water and wastewater and split some of my slides a little bit differently. Some of you might see that it's going a little bit technical, and I really apologize if that is the case because I have a tendency to give lectures. I've been a faculty in my past life, so it has a tendency to do that. But giving you the details, I'm sure you will find that we can go through the innovations that are happening. And I think the takeaway at the end of this, you would appreciate that it's there. We have enough water, but we need to manage it appropriately so that both water and wastewater is unique. And what I would like you to carry with you is one single concept. Water is one. Whether it's a water, wastewater, groundwater, drinking water, or anything you want, just take away with one concept that water is one. The title I'm going to speak about is basically innovation for water and wastewater. And as I said earlier, I have a tendency to pack a lot of slides. So I'm going to skip some of the slides because essentially it doesn't give you much into it. But the follow-up slides I would like to talk about a little bit so that you can have an idea of what I'm coming from. I'd like to share my colleague, Sanjay Guleria, who has also been working with us on this project. If you look at NJS Engineers India, we are a teenager in a sense. We are just a 17-year-old company and been doing a lot of water and wastewater work. We only do water and wastewater work, so if you ask us on transportation, we are not the persons to talk to. But water, wastewater, definitely yes. This just gives you a normal government-style design engineering. You have raw water coming in, then the cascade aerators are there, and the aeration, after aeration, normal treatment plant. The four basic fundamentals that go into water. Inside the water treatment, not much innovations have happened. It's been very casual, it's been very regular. If you look at it, filtration, physicochemical processes, physical processes through membranes, until a point when membranes started evaluating, coming into a water sector, especially the micro and ultra, that's where the game changer started. We already knew in the past that we can use reverse osmosis, but reverse osmosis was a very difficult, costly, and so forth. And then next one came into is your disinfection. Oops. Came into your disinfection is basically chlorine, ozone, chlorine dioxide, and ultraviolet light. Why it was going to use ultraviolet light? Because it can give you a very small footprint, started in 1998, 1994. And the largest water plant in the world, 1.3 billion gallons per day, is set up in New York, where they do only disinfection, that too with UV at 42 millijoules per centimeter square and so forth. Numbers are not important, but it gives them entire water to be disinfected. One thing I would like to clear here, it's an innovation came into water side, but please understand that UV does not kill the bacteria. It just makes it nude. That means if they cannot produce it, it cuts the DNA, they cannot produce it, they are not infectious to us. So that's the beauty. So at that time in 1993, 1995, New York actually went into saying to filter or not filter, because they were under the surface water treatment rule to say whether they have to put a filtration plant or can they just go with UV. So that was the very much innovation for disinfection, and now it's being used in a variety of cases, including in India now, water, wastewater, but also using as AOP, that's advanced oxidation processes, where you can get hydroxyl radical, which is the highest ranking oxidant available that can take up a variety of umpteen number of contaminants in the process. Then the membranes came in. These are basically the hollow fiber membranes to tubular membranes to ceramic membranes. So the advancement went slowly from normal filtration process, which is your sand filter, to membrane, which is 0.1 micron or 0.01 micron or 0.001 micron and so forth. And the particle shape starts getting lower and lower into the process and giving you a cleaner water. So that's an advancement. Change the size of the plant, change the footprint of the plant, so that gives you much better applicability in terms of water availability, because you can get 98%, 97% plant flow without having much reduction going back to backflow and so forth. nowadays, there's a lot of discussion happening. This is just a slide talking about desal. I'm not going to go into details of it, but essentially, the reason I'm putting this slide is because the cost of RO is substantially higher. Typically, the electrical energy requirement is somewhere around 3.2 kWhr per meter cube. This changes the cost because that cost is now being shifted through power generation, through energy recovery, and you can generate almost 45 to 50% energy back. So that's a device that's been generated that gives you much better energy that you're technically using it. So that's an advancement in innovation and so forth. The next one, which is going to be the mind-boggling that is happening, is this. If you look at it, again, this is not a lecture, so just if you look at it osmotic pressure-wise on the top, this is your regular osmosis, reverse osmosis that you use, and forward osmosis. In a sense, how does trees take water from the ground? They basically go through forward osmosis. What is happening in the industry now is moving to forward osmosis. It has come to pilot scale, 10 mLD to 15 mLD size capacity. But why it is stopped for drinking water yet? Because you need a stronger gradient across the water surface so that water can move from one end to another end, and that is exactly happening in the industry side. It will come also on the water side to give you a much better availability. Why it will go so faster? Because if that is going to give you a reverse osmosis to about 2.8 to 2.9 kWhr per meter cube as electrical, this will only give you 0.3 to 0.4. So the cost of water production will go substantially lower regardless of the TDS that you're going to deal with. Normal TDS in your surface seawater is about 37,000 milligrams per liter to 42,000 milligrams per liter, plus changes, plus or minus some percentages. But that will make a life much easier. There are a couple of players in there. DuPont is doing it. Hydronautics is doing it. Suez is doing it. There are several players in this. Will make the change on the water industry in the coming years to go. Again, UV, Internet of Things, which is definitely happening on the water side, which is basically SCADA and analysis. But I would like to point out, in India, we're really not doing SCADA. SCADA is supervisory control and data acquisition. What we're doing now, predominantly under SCADA, is just the data acquisition. We need to start looking at supervisory control. How do I manage? How do I operate the plant? How do I optimize the plant? And so forth. And I can tell you this very strongly because I am a Class 1 certified operator. So I know what it takes to operate a plant, what it takes to minimize the consumption, what it takes to get the water quality out with a minimal discharge of chemicals pushing into the process. You also can have water treatment process parameters, water quality, flow, pressure, you name it. Sensors are there. In a lot of places, the client nowadays in India are asking for sensors. But please be mindful that the sensors need to calibrate every now and then. If you don't have a calibrated sensor, it is as good as giving data which is not required. So we need to have a calibration of these sensors also in a timely manner. Demand and supply management, monitoring of distribution system networks for leakages. There are a lot of now new entities that you can take a ball, put it into a lowest up to 200 diameter pipe, the ball floats through, and you have a GIS connectivity, and you can get a hiss sound if there is a leak. If there is no leak, the water ball passes. So there are several of them. Then there is a argon gas or helium gas you can put in, which is inert gas, and you can travel through the process and get the energy out, and the helium gas measurements are there, and then you can find out. So these are a variety of areas that you can also take the IoT help in the process. Now I want to shift to wastewater. There are two basic parameters in the wastewater. Either you have aerobic process, these are energy consumers, and the anaerobic process. This is sufficient at this stage. We don't want to go into the details of this. But why am I showing this? Because it has got ramification of the treatment process that you utilize to cover the discharge standards that you want to meet at the end of the system. Most prominent in wastewater is your energy consumption. So we need to optimize that energy that is coming from is your energy management, your resource recovery management, and solids volume. And I'll talk about solids volume at the end so I get an idea, because when we talk about water, wastewater, we only talk about the liquid side. You need to also take the solid side into consideration, because that's where the money is at this stage. That's where the amount of recovery on your interest should be there in the process. This is just a different slide showing, instead of normal activated sludge, you can have hanging sponge, you can have smaller areas, smaller materials put in, basically changing the surface area, reducing the footprint of the plant, and so forth. Oops, got stuck somewhere. There we go. Then there is one, this is in Japan that was developed called DHS, downflow hanging spludge. Same idea, change in footprint, smaller footprint, bacteria grows inside the process, and you can reduce your systems. ATBC, this is another one that is developed by Toshiba and ATBC Corporation. Essentially, it has got old rotating drum contactors, but has got a covering on top of it. If you look at the covering, this is the covering at the bottom, and then has got bacteria ingrained into it so that they will do the trick that you want to reduce it. Next concept was brought in by Netherlands, very unique, is creating novel removal through your SBR Nareda process. Essentially, you are forming a globe of bacterial conglomerate with solids, and then that globe and the solids act like an anoxic, anaerobic, outside, inside, and process the system. So you can get nitrification and denitrification at the same spot while not changing the equipment into the process. There's another one, this is called as Organica from Austria. This is water combination with the plants and combination with aeration. And so but this is, I think, built in India now. It's a 50 MLD plant, if I believe, built in Calcutta by L&T, if I'm not mistaken. This is a beautiful process where you can look at it and have that innovation seen because it looks like you're in the garden. And it does need to appreciate that you are not getting a smell, you're not getting anything else. It looks beautifully from outside. Here's again, the membranes can be utilized. What's the next big thing? Because if we are looking at nitrification, denitrification, that means ammonia going to nitrate to nitrite, and then nitrogen at the end of the process. Currently, if you look at the top, we require about 4 to 6 kWhr per kg of nitrogen. Essentially, you go from ammonia to NO2 to NO3, back NO3, and then nitrogen. If you look at the second one, there is a cut process happening. And essentially, I would like to point this out. This is not engineered system. Please keep in mind, better than us, Mother Nature is a much better engineer and much better material handler than us. All you need to do is tell the bacteria, hey guys, you want this particular process, a little bit lower oxygen, a little bit more food, they will act for you. This is exactly what happened there. And if you come back at the last slide, it reduces from 4 to 6 to 1 to 1.75. Energy reduction is substantial because nitrification typically takes a lot of energy to move ammonia that comes into the water to move out to nitrogen and so forth. I'll give you one other example. This is the latest happened through a company called OxyChem, then later on bought by DuPont. It's another way of looking at it, what you need to do in terms of reducing the energy consumption. If you take a normal sedimentation basin, in aeration basin in your wastewater plants, and if you look at the bottom, these are normal headers where aerators are coming out, the air bubbles are coming out. Normal depth is about 3 to 3.5 or 4 meters. There is a definite amount of head required for the bubble to transfer the air from the bubble into the water so that the water gets perfectly oxygenated. There is a limit to it, how much it can do. It can do only 30%. That's the current situation. That's why you need a larger amount of bubbles. There is a larger amount of pressure, and there is a larger amount of energy required to push all of that. What has changed now is what is called as MABR, membrane aerator bioreactors. In the earlier versions, we have seen membrane using as a separation material. That means separating between solids and liquid. Whereas now the next one is they're pushing air through the membrane, and because of that, you get simultaneous nitrification, denitrification on the surface of the membrane. Essentially what happens is air is pushed through this. If these are the brackets, you can lower that down into the existing tank and then push air through that. What happens because of that, that you get almost 75 to 85% transfer of oxygen to the water, thereby reducing your requirement for oxygenation, your requirement for blowers, your requirement for pipe sizing, and then you can also essentially go deeper. If there is a space requirement or there is a space problem, you can go, instead of 4 meter, you can go 6 meter to 8 meter and develop this particular aspect of treatment. So this is going to be the future, and it's already been happening. And I believe NMCG, or National Mission for Clean Ganga, is already talking to DuPont for a program called ETV, Environmental Technical Verification Program, where they can bring in and provide this particular technology and showcase it for us in here. As I said, bubble aeration device, both versus biofilm formation and support nitrogen reduction on the removal on the side itself. Now, next paradigm shift I want to talk about next couple of slides is, yes, we do water treatment, we waste it, say 80% back to wastewater, but what we do with that wastewater, why do we waste that? We can't use it, or can we not use it using concept one water? And if I look at it, if I put million liters per day on y-axis and time scale, if this is the availability of water today, this is the population demand growing from now to 2050 or 2055, and this is what is going to happen to my water availability if I don't appreciate the water that I'm wasting. So do that. If I need to look at it, this is a slide, I took it from the Honorable Jal Shakti Minister last time before the new one came in, Patil Saab came in. Before that, Mr. Shekhawat, from him, I took the slide. Essentially, we're saying that large population or large amount of water is irrigation, 85%. Now they are also moving to safeguard that water to drip irrigation and controlled irrigation and so forth and so on, and then moving amount of water back to the cities in the process. This is the slide I want you to take away today if you have that interest in saving the water, and I'll walk you through. If I use a treating wastewater or responding to the new normal, and I say, no, it's not a new normal now. What is it? Is I have energy factory because I can generate energy from the sludge that is being generated. I have generated nutrient, and I'll show you how you create nutrient because phosphorus is very limited in the world. The phosphorus fertilizer is very limited. So you need to create more. How do I create it? Because in the wastewater, you typically get 5 to 7 milligrams per liter phosphate in your wastewater because of laundry waste, because of a variety of waste. Can I use that to recover? Yes, you can. It is not becoming fully cost effective, I understand. But over time, it will become, but that's an innovation that we need to look at it. Lastly, water factory. It's not a wastewater. It's a water factory providing water. I would rather always say augmentation of surface water is feasible through this approach. So rather than waste stream, I will say value stream, because that's where the money is going to get more into the process. What happened here? Let's go. Now when we talk about recycle reuse, moving from conventional to unconventional, if you look at it, there are no regulations directly involved in India at this stage. There are certain in the Western countries. And if you go at the top of the things, potable, either indirect potable or potable, then there are certain regulations have been formed. For example, California is the only second state. Colorado is the second state, first state. California is the second state. Florida is making right now. Some of the things are happening in UK. Some of the things are happening in Australia, where you are looking for indirect potable. What is indirect potable? Indirect potable is you treat the water of highest quality, put it back into a reservoir, and then take it on the other side for treatment and distribution. Why it is more famous? Because I call it as a psychological barrier. Technologically, I can give you any quality of water. You can get any quality of water you want, including the bottle in front of you can be given to you with the wastewater treated to that quality. But at the end of the day, it's a psychology overcomes the technology and says, nah, it's a wastewater. I can't do that. That needs to be starting to change when we look at it. These regulations need to come, and we're working on it. I'll show you in some of the slides what am I working on. I'll give you one classical example that we have worked for. I was the lead design engineer for this. When we did a project in Agra, if you look at it, Yamuna, when it flows from Delhi onwards to Haryana to Agra, it is literally exhibiting currently secondary level sewage. 30 to 40 milligrams per liter BOD, 40 to 45 milligrams per liter ammonia, and so forth. In the previously, when they were working on it, they were using chlorine as a strong oxidant. You walk into that old plant, you start crying, because they were using 85 to 90 milligrams per liter oxidant dose or chlorine dose, all effervescence coming in, you can start crying into the process. Funded by JICA, and at that time, Government of India, Ministry of Housing and Urban Development, we suggested that let us do this as a wastewater portion first, so that we can utilize that ammonia, we can utilize this biosolids, we can utilize of BOD coming in, and then put a filter instead of regular sand filter. Let us put a membrane filter so that it has a physical barrier so that nothing will escape. This plant is working for last 12 years consistently. And Honorable Prime Minister at that time inaugurated this and gave a very handful thanks to all the people who worked on it. So if you look at it, the top portion is working like a wastewater. It is a moving bed biological reactor. Microbes grew. I don't have a picture here, but microbes literally grew inside, did the trick they want to do. And as I said, if you engineered it properly with Mother Nature's help, you can get it what you want in your sort of footprint. And then essentially you can get very clean water. It's going right into their distribution system and so forth. And I'm very honored to say that we received not only one award, we received 2 awards, one in Singapore and one by Mahua in CPHEO. It's there in the water and water treatment manual saying that if there is a dirty water or dirty river flowing by and you want to utilize it, please use this type of a treatment. Now, I'm not saying this is cost effective. It is a little bit costlier. But you can solve it rather than bringing it fresh water from a far distance to do the trick and then have a cost of pumping and have a cost of distribution. You can get that through the process. This is what I want to get you to, the couple of more slides into this. Traditional source, you can take groundwater, surface water, and then conservation. You can take rainwater, rainwater harvesting, and so forth. When I think the earlier DG was there in NMCG, they had come up with a nice tagline, catch the rain where it falls, when it falls. That's where your conservation comes into picture. And you can use it fertilizer, you can do it groundwater upgradation, and so forth. But you can also take seawater, wastewater, industrial. Essentially, you can get a one water concept in the process. Basically, it's an integrated planning and implementation approach to managing finite water resources for long-term resilience and reliability. Why am I saying this? This is what we are doing in Mumbai. Mumbai has enough water, but they wanted to do, how do they sustainable in the future if the rain doesn't happen, and suddenly last 10 days it has rained so heavily, so all the reservoirs are full. But it's not going to be there. It's going to be erratic down the road. So they are also looking at right now, how do I treat a particular plant water, wastewater, to take it to a drinkable quality or to the level of drinkable quality. So essentially, in a blended direct potable or potable, indirect potable, you have 3 basic parameters that you need to look at it. The foremost important, leave aside technology, leave aside everything, the public outreach program is the most important. In that project, what we're doing, it's a 12 MLD plant, and a 0.1 MLD or 100 meter cube per day pilot, put it in a tractor trailer with all the processes worldwide known and being used in California and other places, being operated there. It's under a bidding stage. It'll come out probably another 4 to 5 months operable. Please do come, because one of the interesting facts what we're going to do, if Singapore can do it, we should be able to do it also. We will put a bottled water plant at the bottom, 250 ml bottled. We'll distribute to you, drink with you, and make it proof. See, ultimately, you can get the water. You need to remove the public stigma and say, okay, this is available. But what makes this type of water quality, what makes this type of process more important is data, 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 and the facts and the factual information given. You can't say, oh, this might be a possible, no, you have to give a full-scale data, you have to give a full data and get a trust. That's the driver on this type of water that is going to happen. Essentially, these are all processes will be built into the process. We'll have a 0.1 MLD going for 2.5 years during the construction phase of 12 MLD. So definitely once it starts, please give me a buzz or email, and I'll be happy to have you there. This is what we've done last couple of years, taking different projects, and USAID funded this for Delhi Jal Board when we did the project, and we put Singapore's bottle next to Kinley and Bisleri, and then also USAID bottle. So we know what is there. We know what can we get and where do we need. This is the project, so we've given a title. Together, let's create pure water from used water, and we gave a name title, Nav Jeevan, Nav Neem, Jeevan, life and water together. Digital twinning, same case we can utilize for balancing act, for maintaining operation and so forth, and visiting rapidly, we can change the game changer for operations and operation systems in the process. Internet of Things, same issue. We can have a lot of sensors, data-driven, data analytics, and so forth. So you probably have that. And the last one I'm going to go, now we talked about water, but there's something else we need to also take care of it. We have not done that, is solids. And what solids can give you is you can give you energy, you can give you carbon, it can give you fertilizer, and also your reduction in the volume and case so it doesn't get pollute the rivers downstream. So I'm going to talk about mainly the lower portion. We just finished a study for the Delhi Jal Board where we can also, NMCG, we were working for NMCG under the Norwegian grant to do a manual and distribution discussion with CE Ganga, NMCG, and Norwich. And this is where we come up with that you can literally do power generation, bio-CNG, gasification, pyrolysis. We also did pyrolysis using torrefication, where we can take the dried sludge, use that to make briquettes, and from this briquette you can use about 10 to 12% as a additional power, additional fire fuel for the process. This is what it is, sludge torrefication, and gives you briquettes. Why briquettes? Because it's easier to handle. If you take the particulate matter, it's also explosive. It becomes very risky to handle and becomes an issue down the road. There is another process which is out there called Austera, which is basically generating exact amount of pellets of phosphorus, phosphate fertilizer. You can utilize that because you can get magnetite, you can get polyphosphates into your digesters. That can be utilized to make this particular process. Lastly, this is the slide I want to say. This is for STP and sludges all over India. We're now doing the second phase of the project with Norwich and CE Ganga and NMCG to now come up with the regulation, what to do and how to utilize this sludge as a carbon source, as well as fertilizer, as well as any other material from, provided your sludge does not have a lot of contaminants or a lot of heavy metals in the process. And this is my last slide. What I would like to suggest and put in front of you is basically how do we need to go from today to 2050 is we need to put innovation, training, and certification. We can create measures of R&D into private and public institutions on water and wastewater reuse. Use 10% of your project cost to develop new ideas, new pollution systems, and new systems. Then we can go 25% on aquifer storage, recovery, water augmentation, recycled water, and so forth. And then strengthening of existing new sewage collection, sustainable operation, WTP, and so forth in the last 60%. That means business as usual, but add these 3 points to the process. And I think that ends my presentation. Thank you very much for your time. Please take one concept, one water. Thank you very much.